Hello everyone, welcome back to Learning Physics. In last lecture we discussed ordinary derivative when we have only one variable of a function. Now let's suppose we have two or more variables. Like a temperature field have three variable temperature inside the room. If we go from one point to other point in three-dimensional space, and then we can model the temperature field in three dimension like t x y z. So every point in x y z space have a different temperature reading. So if we want to generalize the definition of derivative for three dimension, then as per definition of the derivative, we need to check the derivation at every point. That means we need the derivative at every single point into the space. So we need to find infinite directions to find the derivative in infinite direction. But there is a theorem. This theorem is on the partial derivatives. If we want to find the change in the temperature is dt. So you can find just taking three derivative, that is partial t over partial x in x direction plus partial t over partial y dy plus partial t over partial z dz. So it says if you want derivative in any direction, the change in temperature in any direction, you need only three derivatives with respect to x, y, and z, and it will give the change in the temperature in required direction or at required point. So this is good theorem in the sense we only need three derivative to find the change in temperature in any direction. If we go further into it, so to express dt in terms of vectors, so we can write dt is equal to partial t over partial x unit vector plus partial t over partial y unit vector plus partial t over partial z unit vector dotted with the length element where we are moving. So length element in excuse me, in x direction is dx, in y direction is dy, and in z direction is dz. So if we have length element in the direction we are moving, we can multiply length vector infinite for change in that direction with a vector quantity which is change in the temperature. So by definition, this vector quantity is defined as delta t, and delta t is partial t over partial x plus partial t over partial y, and partial t over partial t, z. So we call this quantity a gradient. So gradient is in fact three-dimensional counterpart of ordinary derivative, where we have only one-dimensional quantity. So the whole thing we can express this as gradient. So the change dt can be written as delta t dot dl, where we know the dl is this vector. So here we can see this delta t is vector quantity, and we have to explore its meanings. What does delta t means? Is a vector quantity, but what it's going to tell us now, or what is the meanings of gradient of some quantity? So geometrical meaning. So if we express the above quantity dt is equal to delta t dot dl, it will become, the magnitude will become delta t dl cosine of theta. It's a scalar quantity and after taking the dot product. So if we are where again, if the where the angle cos of theta is the angle between delta t, theta is between delta t, which is gradient, and the length element dl, which is both are vector quantities. So when will be dt will maximum? Dt will be maximum when we have cosine of angle 0, when we have theta is equal to 0. So delta t TL. So maximum change, delta T is change in temperature, right? Delta T is change in temperature. And it will be maximum when we will move as per dt, sorry, dt is change in temperature. And dt is maximum, dt is maximum when we move in the direction of delta t. So when dl and dt are in the same direction, then dl and delta t are in the same direction, then dt is maximum. So the gradient, in fact, which is delta t, gradient delta t points in the direction of maximum increase of function t. So as we saw that dT, the change in temperature is maximum in the direction of delta T. So the delta T is in fact telling us in which direction there is maximum increase in a function T. And if we talk about the magnitude of delta T, then is the slope along the maximum direction. So if you imagine that you are standing on a hill or hillside, so the steepest accent in the is the direction of delta t, the gradient, and slope of that in that direction is in fact magnitude of the gradient. So if we have, say, delta t is equal to 0, that means we are at the minimum or the maximum or the path of the function t. So like ordinary derivative, if we have d for dx is equal to 0, so it points or it signals the maximum or minimum of that function. So similarly, this will tell us minimum or maximum or the path of function t. We have an example. An example is 3 in chapter 1, example 3, and we are given r, which is x squared plus y squared plus c squared under root, and we are asked to find the gradient. Find gradient of r. So gradient of r will be, in fact, we have to find del of r. Then del of r will become delta is operator. Operator is partial over partial x unit vector. We have to put x unit vector on the side. Is plus partial over partial y unit vector plus partial over partial z. Sorry, again I have to put y here and z. And then we have r. So it will become partial r over partial x plus partial r over partial y plus partial z over partial r over partial z. So we have to take derivative of r with respect to x, y, and z, all three. And when we will take the derivative, it will become 2x divided by x square plus y square plus z square, and under root 2 1 by 2, and still x unit vector plus 1 by 2 2y x square plus y square plus z square under root y unit vector plus 1 by 2 2z x square plus y square plus z square under root and z unit vector. So 2 will cancel out with 2 and 1 over x square plus y square plus z square can be taken out as a common, then it will become x unit vector y unit vector plus z unit vector. So this is vector r and this is magnitude of vector r, so it will become unit vector r. So the gradient of r is unit vector r. So what it's going to tell us, so it's saying the distance from the origin is the change in the distance is maximum in the direction of r or unit vector r. So the that's true because the change in r is maximum radially outward. So that's what it's saying. So the gradient again is pointing the direction of maximum change into the function, and magnitude is the slope. For slope for this function r is 1 in this case. So magnitude is delta r is equal to 1. So we will continue with the next section in next lecture. Um, Thanks for joining. And if you have any question or you found any mistake, please comment below to let me know for the correction. Thanks.